Well, hi guys, this is Chris from Pyramid Communications. Today we're going to take a few minutes just to get into the details of Pyramid's multi-vehicle priority structure, which is used on all of our vehicular repeaters. So no matter if you're using an SVR 200, 250, P250, P255, DMR, or NXDN version vehicular repeaters, the basic rules of this priority structure tutorial that we're going to go through today apply to all of these products. All right, so let's get started. The first thing that we need to understand is that there's actually two different types of priority structure. There is the legacy priority structure, and that's originally what was developed by Motorola back in the 80s. We've adapted that into our SVR 200 analog vehicular repeater. Now it's also included in all of the newer vehicular repeaters as well. So all of the 250 series, the P250 series, and the D300 and the N300 DMR and NXDN vehicular repeaters as well. So when they're running in analog mode, pretty much any of the vehicular repeaters can use the legacy priority structure and be backward compatible with an SVR 200. Now once you get into digital mode, instead of using audible tones and analog tones, you're going to be using things like NAC codes or DMR talk groups or NXDN RAN codes, things like that. So that's kind of some differences there between analog and digital. And we won't touch too much on that because it just kind of muddies the water. What you really need to know is the details of the legacy structure and then the enhanced priority structure, which is the Esp structure. That's on all of the SVR 250 repeaters. So your SVR 250, your P250, your P255, and then also your 300 series, including the SVR N300 and SVR D300. Okay? All right, well, first thing to understand is really the purpose of the priority structure. Without the priority structure, you're really just creating a link between two different RF frequencies. But the magic of the Pyramid vehicular repeaters is this priority structure. And its purpose in life is to automatically establish a priority vehicle when there's more than one vehicle on a scene. That's really important. And then if there are multiple vehicles on the scene, to reestablish a priority vehicle if the priority vehicle that was handling all the traffic happens to drive away. And then it also, as a third aspect, detects and automatically clears if there happens to be more than one vehicular repeater on the scene at the same time in the priority state. And that can happen if people don't follow the rules of turning their vehicular repeaters on only when they arrive on the scene. So that's the basics of the three steps. And we're going to go through them all throughout this presentation. Okay, so the first thing we're going to do is just kind of establish a few terms. Now, BTP, or base to portable usage, is the traffic that's coming from your base, aka your dispatcher or other people on the radio network, out to the portable radio network. The vehicular repeater is a bidirectional device, so it's actually repeating traffic from your dispatch system out to your portable radios and in the other direction, which we would call portable to base, or PTB, from your portable radios back out to the network infrastructure. Okay, and we're going to use those terms a couple times through the presentation. Now, when there's only one vehicle on the scene, it's very, very basic. Obviously, that vehicle is the priority, and there's no other reason for a priority structure at this point. But if there happens to be two vehicles arriving on the scene, that's when things get a little bit hectic if you didn't have priority structure. So if you didn't have the priority structure of the pyramids, then what you would have is, like the picture shows here, two vehicles that would be theoretically in quote-unquote priority trying to handle a call at the same time. And what you're going to get is heterodyne. In other words, two carriers on the same frequency at the same time colliding with each other. And that's one of the beauties, and kind of jumping ahead to step 3, is that the pyramids automatically detect if there are duplicate priority units on the scene and clears that out using our methods of priority sampling and ESP. Okay, so in a single vehicle operation, again, pretty straightforward. The priority vehicle is going to handle all the traffic. There's only one vehicle on the scene, so of course it is the priority. Now, if another vehicle arrives on the scene, the first thing that happens is the operator turns on their vehicular repeater. And typically that happens by a programmable button on the control head of the mobile radio, or possibly an external switch or a connection to the radio's park neutral indication that automatically sets up the vehicle to turn itself on as they arrive on the scene. But as the vehicle turns on, it sends out what's called a lock tone or a lock code. This happens both in analog and in digital mode. And that tells the first unit on scene to drop into non-priority. And consequently, all of the traffic now is going to go through the second vehicle on the scene. Now that first vehicle, it's still active, it's still on, electrically, but it's not handling any traffic. It's just listening and standing down, allowing the priority vehicle to handle all the traffic in base to portable and portable to base direction. If a third vehicle is to arrive on the scene, the situation just replicates itself again to vehicle number 3. The other 2 vehicles will now be in non-priority. Interestingly enough, though, they are keeping count of how many priority vehicles that they've actually seen come on the scene after them. And so you'll see the counts here. Count number 1, count number 2. Count number 2 is the first vehicle to arrive on the scene. Count number 1 was the second. Count number 0 is the priority unit. So as the priority unit drives away, in this case, what will happen is you'll be left with 2 vehicles that are in non-priority. And this is kind of where the differences come between our ESP technology and our legacy technology. But follow me here. Even though there's 2 units on the scene left over, they're both in non-priority. There's nothing that told them to take priority yet. But if there is a condition to repeat in legacy format, what will happen is the units will decrement their priority counter, and whichever unit hits 0 first is going to take over the priority, and it's going to assume the priority status, begin repeating traffic, and the unit number 1, the first one on the scene up at the top here, it's going to decrement, hit count 1, but then it's going to start seeing traffic. It's going to stop counting down and allow the new priority unit to handle all of the traffic on the scene. Okay? Now, there's in base to portable direction, there's something called priority sampling that happens now. If you get 2 units in priority at the same time, and this can typically happen if a user doesn't follow the rule of turning on their vehicular repeater as they arrive on the scene and just leaving it on all the time. I mean, sometimes they have better things to worry about. Sometimes maybe they just don't want to follow the rules. What can happen is you do get that situation where 2 units are in priority. But we have a method in the vehicular repeater called priority sampling. It's a self-clearing mechanism that pulses the transmitters of the pyramids, looks for a collision with another vehicular repeater, and if it detects the collision, it automatically stands down, and one of the unit will go into non-priority, one of them will remain in priority and continue to handle that traffic. You don't really know which unit is going to take priority, but it's whichever one sees the conflicting traffic first. So that is basically how that works. Okay, so that's pretty much a real basic rundown of our legacy priority structure. What we're going to go into next, and some key takeaways here, by the way, before we wrap it up. The repeaters must be enabled as they arrive on the scene. In other words, they can't leave them on all the time. They're off when they're driving. They're enabled when they arrive. That alleviates that very last scenario that we went over when 2 units happen to be in priority. There are some fail-safes in there, like the multi-vehicle priority structuring, which is the priority sampling, rather. To recover from that, but it's not something you rely on a daily basis. If a priority vehicle leaves the scene, it takes about 800 milliseconds of traffic, or AKA a condition to repeat, for the non-priority unit to bring itself back into priority. So that's something to know. And really, training is very key to using the legacy method. And you're kind of going to see why in the next couple of slides here. So now we're going to get into the ESP structure. Now, ESP is everything that we've learned so far. So in other words, it still establishes the last car on the scene as the priority. It still has things like priority sampling if you're in analog mode. There's still that lock tone or lock code that goes out on power up. But what also goes out is a beacon. We call it our ESP beacon. Every 10 seconds, the priority unit sends out a beacon. That tells other units that there's a priority unit on the scene already, and they'll stand down. So in other words, if you have 2 units on the scene that happen to be in priority, because maybe they didn't turn them off as they were driving around and left them on when they arrived onto a scene, that beacon will resolve the conflict without having to have a collision occur and relying on that priority sampling. So in other words, because the beacon goes out all the time, even when there's nobody using the vehicular repeater, the beacon resolves the conflict of two units being in priority, and it also resolves if no unit is on the, or no priority unit is on the scene, because maybe the priority unit drove away. If the non-priority unit doesn't hear the beacon of another unit on the scene, it will assume priority by automatically assuming the priority status when it stops hearing that 10-second beacon. So the absence of the 10-second beacon will actually bring it back into priority as well. Okay, and then remember, the last unit on the scene is the priority, and that priority unit is going to be the unit that handles all the traffic in both directions. Okay, well, that's about all I had to say. I wanted to keep this short and sweet here. Just to wrap up a few takeaways on the ESP structure. It intelligently establishes a priority without as much user interaction. So in other words, if they forget to turn the units off as they're driving around, it resolves that priority during the idle time by using the 10-second beacons. It's a little bit more tolerant to people leaving them on, although it is still a rule that you turn them off as they're driving, turn them on with a button or a toggle switch or a connection to some sensor in the vehicle as they arrive on the scene. ESP is an exclusive feature of Pyramid's vehicular repeater, so you won't find that in any backward compatible repeaters for other manufacturers. Thank you for your time, and if you have any questions, please give us a call at 800-485-2881. We'd be happy to answer your questions.